Hi, welcome back. This video lecture is about the automatic dependent surveillance broadcast. Automatic surveillance broadcast technology is transforming aviation, providing real-time situational awareness for the pilots and controllers. ADS-B enables an aircraft to broadcast its position information derived from GPS. Aircraft broadcast its identity, velocity and other information with a high degree of accuracy and integrity. Ground stations receive the information transmitted by an aircraft and sent to ATS surveillance systems, thereby providing enhanced situational awareness to the air traffic controllers. Originally known as Future Air Navigation System, now matured into the system known as Automatic Dependent Surveillance. It is automatic because it requires no pilot or controller input. Dependent because it requires operating airborne equipment like transponder. Surveillance. The information received is used by air traffic controller to provide surveillance services. Broadcast. In this system, the aircraft has a special transponder that broadcasts information of aircraft position, speed, altitude, state vector at a much higher rate of twice per second. ADS-B broadcasts its position automatically at a very high update rate of twice per second. This information is used for real-time surveillance service by air traffic controllers. This coverage is limited to the line of sight. ADS contract. The reports such as top of climb, position reporting points at specified time interval are sent by aircraft in accordance with a contract set up with the ground ATC system. These reports basically replace verbal reports from the pilot and facilitate the application of procedural separation in oceanic airspace. Radar signals are sent between radar and aircraft transponder to calculate aircraft position. Radar updates air traffic control system with the information about the aircraft every 5 seconds. An aircraft with ADS-B capability determines its position using GPS. The Mode S transponder then broadcasts that position at rapid intervals, along with identity, altitude and velocity information. Dedicated ADS-B ground stations receive the broadcasts and relay the information to air traffic control for precise tracking of the aircraft for radar control. The ADS-B data link supports a number of airborne and ground applications. Cockpit display of traffic information, airborne collision avoidance, improved search and rescue, airport ground vehicle and aircraft rescue and firefighting vehicle. Operational needs, oceanic control. ADS-B consists of 3 components. Transmitting subsystem, transport protocol, receiving subsystem. Transmitting subsystem generates message in aircraft and broadcast it to all. Transport protocol. Currently there are 3 kinds of data link: Mode S 1090 MHz extended squitter, VHF digital link mode 4, and universal access transceiver. ICAO has approved the 1090 MHz Mode S extended squitter technology for the data transport protocol to ensure global interoperability. 1090 extended squitter downlink format is of 2 different message sets. Short squitter, response signal have a 56 bits, short message. Extended squitter, 112 bits, long message. Types of ADS-B. ADS-B out is the transmission of ADS-B information out from an aircraft to other aircraft or to the ground station. The signal is broadcast at approximately every half a second. ADS-B in it means aircraft or ground receiver is fitted with ADS-B transmitter as well as receiver. Cockpit display of traffic information, onboard reception of ADS-B out transmission to allow display of nearby traffic, weather, terrain, airport maps to the pilot of an ADS-B equipped aircraft is called cockpit display of traffic information. Flight plan requirement. When requested by ATS to specify the type of transponder carried aboard the aircraft, pilots shall indicate this by inserting the specified characters under item 10 in the flight plan. B1 with ADS-B out capability. B2 with ADS-B out and in both capability. ADS-B surveillance quality indicators. Ground verification of ADS-B data is not performed. The ground receivers should be capable of detecting, tracking and identifying targets equipped with ADS, B transponder as per ICAO standards and recommended practices mentioned in Annex 10 Volume 4. Aircraft will obtain its position from GPS. Thus, GPS integrity comes into picture. Receiver autonomous integrity monitoring is a technology developed to assess the integrity of GPS signals in a GPS receiver system. Thus, GPS will calculate horizontal protection level, the integrity of the horizontal position from GPS system. This will be broadcasted by aircraft transponder or ADS, B transmitter. The output of transmitter consists of position and other data like altitude, aircraft identification, special position indication, emergency message codes plus NUC or NIC. Horizontal protection level is the expression for the integrity. The true position of aircraft outside the radius of containment will be only 10 raised to the power of -7 per flight hour. Horizontal figure of merit represents the accuracy of the horizontal position of aircraft. 95% of the time the real position of aircraft and calculated position of aircraft by GPS will lie in the radius of containment RC. The parameter, horizontal position quality indicator, integrity and accuracy, are encoded in the transmitted message from the aircraft. Navigation accuracy category, a radius around the aircraft inside which aircraft position reports will lie with a 95% probability. Navigation integrity category, it defines radius of containment, RC. All target reports should lie inside radius of containment, RC. The NIC value is important in ensuring the safety of the system by limiting the probability of false targets being established. Surveillance integrity level, there is probability that aircraft position may be outside the radius of containment and still no alert is received. SIL equals 3. Probability of aircraft position outside RC is less than once per 10 million flight hours. Navigation uncertainty category is adopted to give a combined expression of accuracy and integrity requirements through a single parameter in Radio Technical Commission for Aeronautics, version DA 260. RTCA DA 260 is the minimum operational performance standards for 1090 MHz, ADS, B. As per ICAO, ADS, B information shall be used for the provision of air traffic surveillance services, provided the NUC is equal to 5 or greater. Once received by ground station or other, ADS, B in aircraft, which will determine position and FOM derived from the HPL. The information will be sent to ATC display system using *21 format. * is all-purpose structured Eurocontrol surveillance information exchange is a standard for the exchange of air traffic services, ATS, information. It is developed and maintained by the European ATS organization Eurocontrol.